In this video, we will be discussing Cauchy's integral formula. Cauchy's integral formula. In Cauchy's integral formula, we are actually interested in evaluating integrals of the form integral over c f of z by z minus z naught dz, where c is a closed curve such that f of z is analytic inside c. This function as a whole need not be analytic inside C. The term that we are writing in the numerator, that term we are going to call it f of z, and that term is analytic inside C. In that case, integral over C f of z by z minus z naught dz is equal to 2 pi I into f of z naught. This is the Cauchy's integral formula. I'll repeat once again. We are having a closed curve C such that the term in the numerator, that is f of z, is analytic inside C. Then integral over C f of z by z minus z naught dz is equal to 2 pi I into f of z naught, where z naught is the term associated with this denominator z minus z naught. We will be illustrating this formula using some examples. Consider this question here. We will be evaluating integral over c e raised to z by z minus 2 dz for any contour enclosing z not equal to 2. Okay, so we have taken a representative contour here. We are having a closed curve C such that this point 2 is inside of our closed curve. Then using the Cauchy's integral formula, this integral over c f of z by z minus z naught dz is equal to 2 pi I into f of z naught. Now comparing this with the given question, f of z is e raised to z, and z minus z, in place of z minus z naught we have z minus 2. That is, z naught is equal to 2 and f of z is equal to e raised to z. So f of 2 will be e square. So using the formula, it is 2 pi I into f of 2, that is 2 pi I into e square. So integral over c e raised to z by z minus 2 dz is 2 pi I into e square. Now I'll repeat it once more. If you look at this function as a whole, e raised to z by z minus 2, that is not analytic inside this region, because the point at which it is not analytic is z equal to 2, and that lies inside the curve. But we are only interested in what is there in the numerator. Numerator is e raised to z. E raised to z is analytic inside C. So we can use the Cauchy's integral formula. That is, integral over C f of z by z minus z naught dz is 2 pi I into f of z naught. And we have arrived at the answer 2 pi I into e square. Now the same question, suppose we are doing it for a closed curve C which does not contain 2. Then what happens is, this function as a whole, e raised to z by z minus 2, if you look at that function, the only point where the function is not analytic is the point z equal to 2, and that point lies outside of our curve. It is not inside this curve. So f of z is analytic inside C. So you can directly use the Cauchy's integral theorem which was discussed in the previous video. So it is integral over c e raised to z by z minus 2 dz is equal to 0 by the Cauchy's integral theorem. Now we will be evaluating this question, that is, integrate the function z square plus 1 by z square minus 1 counterclockwise around each of the 4 circles given in this figure here. Okay, so the function is z square plus 1 by z square minus 1, which can actually be rewritten as z square plus 1 by z plus 1 into z minus 1. The denominator can be simplified into z plus 1 into z minus 1. Now this function, if you look at this function z square plus 1 by z plus 1 into z minus 1, it is not analytic at 2 points. That is, one point is z equal to minus 1 and the other point is z equal to 1. Now the given circles are A, B, C, D. This first circle A contains one non-analytic point, that is the z equal to 1. The second circle B, that also contains one non-analytic point, that is the point z equal to 1. The third circle contains one non-analytic point, that is z equal to minus 1, and the fourth circle contains no non-analytic points. So we will be evaluating the integral along the first curve. So C is mod. So if you look at this figure, that is actually mod z minus 1 equal to 1. Now here what we are going to do is, the point where the function is not analytic is the point z equal to 1, or equivalently the term is z minus 1 equal to 0. So I'm going to just keep z minus 1 in the denominator, and all the rest of these terms I'll be taking it to the numerator. So z minus 1 I've kept it in the denominator, z square plus 1 by z plus 1 I've taken it to the numerator. So the term that is there in the numerator, that is your f of z. Okay, so this term that you see here, this is your f of z, and z minus z naught. So z minus z naught, if you compare with the standard form, it is z naught is 1. So using the Cauchy's integral formula, integral over c f of z by z minus z naught dz is equal to 2 pi I into f of z naught, where f of z is z square plus 1 by z plus 1 and z naught is 1. So f of 1 will be 1 square plus 1 by 1 plus 1, that is 2 by 2, which is 1. So the integral, the final answer is 2 pi I into 1, which is equal to 2 pi I. Now the same question we will be integrating using the second contour. Okay, now if you look at the second contour also contains only one non-analytic point. The second curve is something like this. It contains 1 and it does not contain minus 1. So even if you integrate it along the second curve, there also you're only having one non-analytic point inside the curve. So you have to repeat the same procedure as in this question, and you will arrive at the same answer. It is 2 pi I. You're only having one non-analytic point. The third question, this is the given curve. The given curve is this curve C, which contains the non-analytic point minus 1. So the figure is redrawn here. So now it contains one non-analytic point, but it is minus 1. So you keep the term associated with z equal to minus 1 in the denominator. The term associated is z plus 1 equal to 0. So I am keeping z plus 1 in the denominator, and all the rest of the terms I am taking it to the numerator. So in the numerator I'll be having z square plus 1 by z minus 1. The denominator is z plus 1. So your f of z is z square plus 1 by z minus 1, and z naught, if you compare it with the standard form, that is z naught is equal to minus 1. Okay, so your f of z is the term in the numerator. F of z is the term in the numerator, which is z square plus 1 by z minus 1. Z naught is minus 1. So integral over c f of z by z minus z naught dz is equal to 2 pi I into f of z naught, where f of z is z square plus 1 by z minus 1 and z naught is minus 1. So you are having the final answer as 2 pi I into minus 1, because f of minus 1 is minus 1 square plus 1 by minus 1, which is 2 by minus 2 minus 1. So the integral value is 2 pi I into minus 1, which is minus 2 pi I. Now moving on to the last part of the question. The last curve is this curve D, and D, that curve, it does not contain either of these two non-analytic points, minus 1 and 1. Both of them are outside of the given curve. So what that means is, the given function g of z, that is z square plus 1 by z plus 1 into z minus 1, is analytic inside the given curve. So you can directly use the Cauchy's integral theorem. So by Cauchy's integral theorem, integral over c f of z dz is equal to 0, since that given function is analytic inside the given curve.